Okay, you guys, here's your lesson for Monday. Today we are doing 12.5, and it's going to be called the recursive formula. As I kept mentioning to you guys last week, there's something called an explicit formula, and there's a recursive. So now hopefully they will make sense since you have already learned what explicit means. I will go through it once more, just a quick review. So for explicit formula, so let's go through that one more time. Or I should say, let's review what it means to be an explicit. So explicit formula is basically a rule in which you can find, we'll say, any term. As long as I give you the formula, or the rule, you can sub in any position, the 10th position, the 30th position, and you can find any term. Okay, so that's for recursive. Now today, just as a review, that was why I wanted to go do that, I'm teaching you guys recursive. Okay, so what the recursive rule states is it is a rule in which any term, so kind of the same thing, of the sequence except the first can be, we could say calculated, we could say found by using the previous term. So this is big. This is something different than what the explicit. Explicit, I can ask you right away, given the two formulas, and maybe we should review our two formulas. For your arithmetic formula, we know it's a sub n equals first term plus the common difference, n minus 1. And then we know for geometric, it's a sub n equals first term, common ratio, raised to the n minus 1. And I could ask you, using the explicit formula, to find the 30th, the 40th, the 50th term. Well, the biggest thing with the recursive, like I just mentioned, is you can only do this. Each term, we can say, can only be found, by knowing / again using previous term. So really what this means is if you want to find the third term, then you better know the second term. If you want to find the 10th term, then you better know the 9th term, which means if you want to know the 9th term, you have to find the 8th term, the 7th term, the 6th term, and the 5th term. So that's the huge difference. Again, explicit, you can find any term you want right off the bat. You just substitute it in. Recursive, the only way you guys can find the 10th term of a recursive is if you knew the 9th term. And the only way if you knew the 9th term is if you knew the 8th term and the 7th term, the 6th term, the 5th term, and so forth. So it's definitely a huge difference. There's a little thing with the recursive formula that has to be found or has to be told or known. So let's write this down. This is very important. Our recursive, you could say rule / formula must have two things for us. So again, very important. The recursive has to have these two things. The first thing it has to have is what we call the initial condition. What do I mean by that? It means, we'll say, the value of the beginning, or and for us we could say the first term. or terms, and you're going to learn that. Meaning I must give you, let's say for example, I must give you a ones formula or term. Just understand I can also say a to the 0. That means the same thing. What this is just going to say is the first term. So please understand if I say a to the 0, it's the same thing as the first term. I have to give you, again, the first term. The initial condition I have to give you, as you should recall, and it should make sense, if you're going to use the recursive, the only way to get each term is by using a term prior. And as I wrote to you, accept the first term because you need the first term. So it needs the first term, and then you can get every other term. The second thing I must give you is we can say the recursive's rule. So the two things I have to give you. And what the recursive's rule is the same thing. It's pretty much what you did with the sequence. It is your equation or your rule used to get the next term. And again, it's based on using, yep, you said it, make sure you know this, the previous term. Now, the way I can represent the previous term, again, very important, is if I say a and then a subscript n minus 1. Or I could say a subscript n minus 2. Please understand, let's just take a peek at that. What that means, if you guys take a quick look, okay, that doesn't work. Think about this. If I said a of 3, and if you substitute, again, if you remember, this is a sub n is 3, so I'm going to substitute 3. 3 minus 1. This is saying, hey, I want a sub 2. A sub 2's answer, which makes sense. Ready? If you want the third term, which means you need to know the term before it, which was the second term. So this n minus 1 is the term right before it. Well, let's see what this n minus 2 is. If I said again, I'm looking at the third term, if I substitute 3 in, then this is the term I want you to use. So again, you have to use a prior term. I would have to give you a formula. So this says, hey, if you want the third term, you have to use the first term and something else. So n minus 1 makes sense. One term right before it. N minus 2 is take 2 terms right before it. So hopefully that makes somewhat of sense. This needs, again, to be the recursive rule, your initial condition. Let's say that's your initial, and then I have to give you some kind of rule. Hopefully that was just a very basic understanding of what it means. Now let's take a look at some problems. Just like we did with your other lessons, I'm going to number the problems. That will help you for your homework. That'll help you for when you guys are studying and when I can tell you, hey, reference this question. All right, so first type of question I could ask you from the recursive rule. Here's your question. Let's write this down. So the question can say, write the first 4, very basic one, let's do very basic, first terms of your sequence given. Okay, so just write this down. All right, so let's discuss what we have here. This, as I told you, is your initial. I know it says a sub 0. Don't worry about the fact that, it says a sub 0. It just means the first term. So this is your initial condition. And here you go. This is your rule. So let me show you what it means, and maybe after I do it a couple times, we'll be fully understanding of it. Well, as I told you, a sub 0 equals 1. This is my first term. So that means we want 4 of them, right? So here, a is 0. I want 1, 2, and 3. Hence 1, 2, 3, 4. I don't care what number I put there. It just happens to be that. And then you're going to use the rule. So I'm going to write the rule over and over just so, again, it makes sense. So if I substitute or write this, Just bear with me. Okay, so what this means, again, if this is a sub n, actually I probably should have wrote that here. That's a sub n. So that means, again, that 1 is n. So think about this. If I substitute 1 here, 1 minus 1 really means, hey, you guys, I want a of 0's term. And then I want you to add 4. All right, let's replace. Well, we know a of 0, which again is the term, since I said minus 1, right before this. So the term right before a of 1 is a of 0, which is 1. So you replace this with 1. 1 plus 4 is 5, and that's the answer. Stop for that question. Okay, let me explain again. Let's write the formula down. I'm just going to put the actual number in for now. So n, now you understand, n is 2. So let's go 2 minus 1 plus 4. Here, I'll go like that. So the green is what I substituted in. All right, well, 2 minus 1 is 1. So if I rewrite this, hey, I want a of 1's term, and then I want to add 4 to it. A of 1's term, is 5. All right, so let's replace this with the number of 5, because again, what that says is give me a of 1's term. So 5 plus 4, 9. That's your second or third term. Makes sense. N minus 1, I want the term right before it, so I want 5, and then I want to add 4, and I get 9. Hopefully you're starting to make sense, and you guys also see why you need the term before it. Okay, let's do the next one. Again, this is my n. Let's substitute my n in. 3 minus 1 plus 4. All right, 3 minus 1 is 2. So what that means is I want a of 2's term, and then I want you to add 4 to it. A of 2. A of 2, the answer for that term was 9. Hey, let me replace this with 9. Because again, this value is a of 2, and let me add 4, and I get 13, needing the term prior to it. So the answer for the first 4 terms are 1, 5, 9, 13. This should make sense. If I take this term and I add 4, I get the next term. To get to this term, I have to take my term prior and add 4. To get to this term, I need to add the term prior plus 4, and that's the answer for that question. I know it looks similar to something else, but you'll see how that works. All right, let's try another example. Okay, So again, I'm going to ask you to write the first 4 terms. Okay, so here I'm giving you A1 is 1. Okay, I'm going to make it a teeny bit harder because I think this is pretty simple to start with. And then I'm going to say, hey, A2 is 4. And then I'm going to tell you, here is your rule. So again, just jot this down, and I will explain it. If you remember, in the beginning, when I told you, if I knew where my paper was, I told you that the value of the beginning, your initial condition, can have the first term or terms. So I can give you more than one term. Here I gave you. So let's change this to actually find me the first 5. Nah, let's keep it at 4. Let's not make it more complicated. Let's keep 4. Doesn't really matter. So 1 and 2, these are my initial conditions. And what this means is I helped you out. You know the first term and you know the second term. This is your recursive rule. Okay, so let's see what this looks like. It wants the 4 terms. Well, here is my first term. Here is my second term. Remember, this is your A of n, so let's kind of do what I did before. If I want to find the third term, I'm going to use that rule, and I'm going to write the rule out, but I'm just going to replace, we all know that this is n, I'm going to replace n wherever I see it, as I put a 3 here, with a 3 here. So this says 3 minus 2, and then I want a minus. And then let's replace again this other n with the 3. So understanding what I just did, I just replaced all of those n's with 3. All right, let's see what you got. Well, this really wants 3 minus 2 is 1, so I want the first term, then 3 minus 1 is 2, minus the second term. This matters. The order is really important. Also, some of you guys are bright enough to realize this. If I say n minus 2, if you want to jot this as a note for yourself, what this means is take 2 terms prior. And what n minus 1, which we already discussed, means take 1 term prior and do your work. So I would recommend you guys doing it like this in the beginning, especially so you understand it. Okay, a of 1. a of 1's term was 1, minus a of 2's term is 4. So there you go, your final answer for the third term is negative 3. Okay, watch again. Now I want the fourth term. Okay, so again, I'm going to substitute wherever I see an n. 4 minus 2 minus a 4 minus 1. Okay, so 4 minus 2 is your second term, minus 4 minus 1 is your third term. Okay, so what is a of 2's term? 4, replace with a 4, minus a of 3's answer is negative 3. And you guys get plus plus, so 7. It's really important you guys take your time, because if you get this wrong, obviously this is going to be wrong for recursive, because recursive all depends on your first term, or the term prior. So here are your answers. 1, 4, negative 3, and 7. Granted, if I asked you for, if I asked you for the fifth term, you obviously, hence this take 2 prior, you'd be taking the negative 3, and then you'd be minusing 4. So it's important to follow the formula, or the rule, 2 terms before minus the first term before. Again, if I asked you for a of 7's term, there's no way you can figure it out unless you knew a of 6 and a of 5. So that's where the recursive takes into play. You have to know the term prior. All right, let's do another example of this, and then I can ask you guys your next question, which is writing the rule. So one more of these, hopefully it should make sense. So again, I'm going to ask you guys to write, what if I can write, first 4 terms. Okay, so here you guys go. A 1 is 2, a 2 is 3, and here is your general rule. So now I'm asking you to multiply. Again, a n minus 1, 1 term prior, n minus 2 is 2 terms prior. This is needed. You need the initial condition. So let's start writing it. Should I keep it consistent? The first term is 2. The second term is 3. Okay, if we want to find the third term, I'm going to do exactly what I did, but I'm hoping that this is easier. So this is my n. I'm going to replace it right into here. So first it's 3 minus 1 times the 3 minus 2. Oops. Okay, so what's 3 minus 1? So this is the second term times the first term. Okay, a of 2 is 3, a of 1 is 2, 3 times 2 is 6. There you found a of 3. Okay, and let's do a of 4. So we have a, let's replace n with 4. Let's replace n with 4. So here we go, 4 minus 1, 3. So we have a of 3's times a of 2. A of 3 is 6 times a of 2 is 3, 18. Again, you guys should be able to pick up. Give me 1 term before and then multiply it by 2 terms before. So here are your answers. 2, 3, 6, and 18. Hopefully you guys start to see there's like a pattern here. Again, to get the third term, we took 2 times 3, we got 6. To get to 18, 3 times 6 gives me 18. So you should start to pick up that the fourth one would be 6 times 18. Okay, next type of question. We're almost done. Okay, so the next type of question I can ask you guys, so let's label this number 2. I could say, now I'm going to ask you guys to write, you're going to write the recursive rule, and we're going to compare the difference. Also, I want us to write the explicit rule, good for review, for the following problems. 1 second. Okay, so here's your first problem. So we got -4, -11, -18, -25. So I want you guys to understand the difference between the recursive rule and the explicit rule and how they're written. All right, so let's first do our recursive, because that's what we're just learning. Please, again, know the recursive needs an initial. All right, the initial is the first term, always. So you always are listing that. So, hey, a of 1 is 4. You want to write a of 0, that's fine. But a1, 4, -4, sorry. a1 is -4, there is your condition. Now, watch, very simple. Your rule is the next. The way you want to do it is first you have to decide. So this is really important. I'm going to put a star here. Now that you learned geometric and arithmetic, your first thing you guys have to decide is you have to decide if arithmetic or geometric, and we kind of already talked about that. Arithmetic is if you have a common difference that you're constantly adding